Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Nasruddin bin PZ with ID AA17145. My supervisor name is TS Nuraza binti Ghazali. I want to present about my final year project which titled The Effect of Pump oil clinker, especially sand replacement in normal concrete towards durability aspect. The presentation outline comes with introduction, problem statement, objective, scope of research, literature review, methodology, material preparation, list of testing, expected outcome, result and discussion, conclusion and recommendation. The introduction. According to Minimal Product Association, concrete is a composite substance that composed of aggregate mixed with water and cement which harden with time. Commonly, concrete were used because can improve sustainability performance of building and structure. In addition, Algate said explained that concrete were secondly most used after water in the world. Statistics recorded by Department of Statistics measure this country construction sector increasing of value gross output with RM204.4 billion in 2090 compared to RM177.9 billion in 2015. Increasing of construction sector increase the amount or use of concrete in the brick substructure and superstructure. According to N. Abdullah, pump oil factory generate waste like oil palm oil shell, oil palm fiber, palm oil clinker and empty fruit bunch. Explained by Karunisa, palm oil clinker is the waste product after process of burning fiber and kernel shell with high temperature. I use palm oil clinker as sand replacement in the concrete. The problem statement. First problem statement is a mining issue. According to Sean, between 32 and 50 billion tons of sand are extracted from the river for supplies around the world and demand are increasing. According to Ashraf, continuous of sand mining affect channel instability and sedimentation of the river. According to Tarito, wideness of river bank and lost vegetation was noted as a serious negative impact of sand mining around the river. Also, loss of lot of vegetation around the river catalyzed natural disaster happen like soil erosion and landslide. The second problem statement is the production of palm oil waste. We can see at the pie chart. Oil palm industry produce 85.5% waste in this country. According to Sher Kachin, excessive of palm oil waste required large space of land for storage dumping of this waste. According to Karunisa, innovation using palm oil clinker in the concrete increase clean environment because reduce of waste in palm oil factory. My objective. The first objective is to determine the workability for normal concrete with pump oil clinker as partially fine aggregate replacement. Second, to determine the optimum mix design for normal concrete with pump oil clinker as partially fine aggregate replacement using compressive strength. Third, to determine the durability for normal concrete with pump oil clinker as partially fine aggregate replacement in the term of acid, sulfur attack, and water absorption. The scope of research. The scope of study of the research as follows. The variable of the research is percentage of pump oil clinker partially replacing the sand as fine aggregate replacement. The percentage start with 0%, 10%, 20%, 30%, 40% and 50%. The SLAM test was conducted according to standard in order to study workability of fresh concrete. Compressive strength test was carried out to determine the strength of the concrete and to identify the optimum mix design. Acid attack test will carry out according to ASTM C267 to determine the resistance to acid. Sulfur attack test will conducted according to ASTM C267 for determine the resistance towards sulfate. The size of pump oil clinker used as fine aggregate was in range 2.36 mm to 5 mm. The coarse aggregate size was used is 10 mm to 12 mm. The design mix will calculated using DOE form to achieve target strength with 25 MPa. Literature review. The finding that I get from the literature, the potential and the importance of recycled aggregate as substitute for natural aggregate in the concrete industry. Second, POC has a follow specific gravity than the conventional wet aggregate. Thus it has lost density and enabled the weight of resulting concrete to be reduced. The concrete containing POC will have a lower density as well as compressive strength than the normal aggregate concrete. Third, POC aggregate was compatible to be used in lightweight concrete mixed preparation. Fourth, the result also showed the optimal replacement content of fine aggregate, which industry weights were 10% for Avondre alum flash, whereas 15 for quarry and limestone. Thus contain the improve of strength properties investigated in this study. For the durability aspect of pump oil clinker, pump oil clinker geopolymer mortar show a great resistance to hydrochloric acid and magnesium sulfate solution. Second, pre-treatment using hydrochloric will enhance the reactivity of the pump oil clinker. Methodology of this study was stated using this flowchart. Material preparation. For the fine aggregate, I use Eversand. For the coarse aggregate, the size of coarse aggregate is 10 mm to 12 mm. The type of cement is a OPC cement with brand YTL orang kuat cement. The pump oil clinker, size of pump oil clinker is 2.36 mm to 5 mm using the water tap and the addition of super plasticizer. Concrete mix design. The concrete will be designed to achieve target strength with 25 MPa by using the DOE method of mix design. The mix design ratio is a 1 to 1.25 to 3 with 0.55 water cement ratio. This is a table of mix proportion in kilogram per meter cube. This is a list of achievements in my research. Firstly is a slump test, compression strength test, acid attack resistance test, sulfate attack resistance test, water absorption test. The expected outcome. Firstly, the expected in the outcome is the expected is concrete with pump oil clinker as an improvement achieves target slump with 30 mm to 60 mm. The optimum design for normal concrete with pump oil clinker as the strength replacement. The compressive strength of the concrete must achieve targeted strength with 25 MPa. The concrete containing pump oil clinker, especially strength replacement, can provide high strength of compression and good durability to acid attack, sulfur attack, and water absorption. We go to result and discussion. Firstly is slump test. The target for slump for the mixture is 30 mm to 60 mm. From the graph we can see the lowest height of slump is a control mixture with 25 mm. The highest slump is on 20% of replacement with 142 mm. We can see from the graph increasing of usage of POC in concrete with reduced the workability. We can see the trend if after 20% to 50% using of pump oil clinker. The inconsistent of my slump height is, I think, is due to poor mix during casting, because the process of casting delay, so the slump the water in the slump easily to leave the mixture. For the compressive strength, this compressive strength under air curing. For 7-day air curing, the highest strength is on 10% replacement with 40.35 MPa, and the lowest is on 50% of replacement with 25.614 MPa. On 28 days ash curing, the highest strength is on control sample with 45.32 MPa, while the lowest strength with 20.727 MPa on 40% replacement. The usage of POC after 20% replacement in the concrete can reduce of compressive strength. Compressive strength under water curing. For 7 days ash curing, the highest strength on control sample with 40.7 634 MPa, and the lowest is on 50% of replacement. For the 28 days of edge curing, highest strength is on 20% replacement with 43.522 MPa, while the lowest strength on 50% replacement with 27.312 MPa. The compressive strength is reduced after the mixture contains more 30% of POC in the concrete. Water absorption. For the water absorption, on the 10% replacement, recorded the lowest percentage of water absorption with 1.92%. The usage of palm oil clinker is good compared to normal concrete because the rate of water absorbed in 10% replacement is lower than the normal concrete. The excessive after 10% replacement of palm oil clinker increase the water absorption rate in the concrete. We can see the water absorption percentage was increased after 10%. The 20% of replacement recorded 2.14% of water absorption. The results show sand has absorbed more water than palm oil clinker from the comparison of 10% of palm oil clinker and 0% of palm oil clinker. Next is a acid resistance test. Acid resistance test was compared with two variation. Is firstly on the weight and the second on the compressive strength. This graph show the percentage of decreasing weight. All the mixture has mass loss after react with acid. The lowest rate of mass loss is on 10% of replacement with 0.470 percentage of decreasing of weight. It's good compared to normal concrete because the normal concrete recorded highest percentage of decreasing of weight with 0.740. Variation on percentage decreasing on compressive strength. The mixture as decreasing of compressive strength. From the result, 10% replacement decreased the percentage of decreasing compressive strength with only 3.52%. Compared to the normal concrete, the normal concrete recorded 16.408% decrease of compressive strength. Usage of I can conclude the usage of clinker reduce the percentage decreasing of the compressive strength. Sulfate resistance test. All the mixture increasing in weight after 28 days was immersed in magnesium sulfate solution. From the graph we can see all the sample record the change of weight. The change of weight was positive because the concrete has weight gain compared to the acid resistance test. Acid resistance test has a mass loss. The increment in the mass of the concrete is a result of aggregate formation which fill in the pores of concrete and increase of concrete volume. The more porosity when more POC usage in the mass concrete affected the rate of change of the mass on the concrete. We can see the normal concrete show the less percentage of weight compared to the palm oil clinker replacement. The normal concrete record 1.61 percentage change of weight. 10% replacement recorded 1.98 percentage of weight. 20% of replacement recorded 2.33 percentage of weight. Percentage change of weight. Comparing about the compressive strength, all the mixture as decreasing on the compressive strength towards sulfate resistant. 10% replacement decrease the percentage of decreasing compressive strength with only 10.24%. It's good compared to 0% of replacement. The 0% of replacement recorded the highest decreasing percentage compared to the 0% replacement. The highest loss compressive strength occur on 20% of replacement because has more void and the more porosity. The 20% of replacement recorded 23.59% rate of decreasing of compressive strength. For the conclusion, firstly, the workability of the concrete decreased after 20% of replacement mixture. The workability of the concrete are over the target slump. For the second conclusion that I can conclude, the optimum design mix is 20% of POC as sand replacement after record high compressive strength for the boss curing. Third, compressive strength show increasing of strength until 20% of mixture, and the continuous reduction of strength after 20% of replacement of POC. Usage of POC can reduce the rate of water absorption. Increase the percentage of displacement show the high percentage loss of mass and loss of strength after exposed in acid solution. The last one is that at Wingate formation in after react with sulfate solution increase of concrete volume. For the recommendation, conduct a series of study the workability of different types of POC as sand replacement in concrete. Conduct study on the compressive strength of different types of POC as sand replacement in concrete. Investigation the durability of concrete contain POC as sand replacement with different size. Okay, that's all for me. For the Q&A session, you can contact me with this phone number. Thank you.